This time we're going to be talking about a couple of things. We're going to be talking about the brainstem and the reticular formation. These guys are just located inferiorly to all the rest of the brain, or if we're going to be using our terminology, it's more ventral than the rest of the brain. It has three parts to it. It has a medulla oblongata, and those of you that have watched Waterboy, delete the information that you got from the fake Colonel Sanders. It is not your center of getting angry. The pons, which is your bridge, and then your midbrain, three pieces. We're going to pull apart these pieces a little bit more, hopefully help you make it a little bit easier to remember what they do. First off, here is a little model that has your medulla, that has all your brainstem intact, along with your diencephalon and insula. Comparing that to that of your the brain, a little sketch by Bjorn Grind of the alligator brain. Notice that this is the most thinky part it has. There's your cerebellum and your olfactory nerve for the alligator. Not much there. What it runs on, this part, this brainstem, this is its vitals. You got your heart rate, you got your breathing, you got a lot of gestational or your digestive portions being regulated here. So we're going to go ahead and talk about the brainstem and its reptilian-like thing. That's why I call this portion more of the reptilian brain, because you would need this to function, but hey, you'll survive without it in a very poor state of being. So the medulla oblongata is continuous with the spinal cord. Remember, just below it, just below the spinal cord, it connects, or this, well, there you go. Just below this medulla oblongata, you got your spinal cord. And which means that all your motor tracks and all your sensory tracks, all those impulses coming from the rest of your body and going out, have to go through this medulla oblongata. In fact, a lot of these tracks go through the pyramids. These pyramids right here have a very special and unique function, and that's that guy right there. This is called the decussation of pyramids. It is where there is a decussation just means to cross over to or to make an X. So this structure right here explains why when you have a stroke on your right side of your brain, the left side of your body is affected. Maybe you have a limp and your left leg is being dragged behind you. It's because something in your right hemisphere has been broken. Maybe your left hemisphere is hurting. That means your right side isn't working so well. The right side of your body isn't working so well. So that decussation of pyramids is the guy that has any type of control over it. Also, you have something called the inferior olivary bodies as a part of it. This is what has been described as the place that helps the cerebellum learn new skills or help coordinate and all that good stuff. Inside this medulla oblongata, inside it has varying types of regions. This is the area where you have your respiratory tract being fluctuated. Your breathing, you got your hiccups and sneezing, swallowing and vomiting. And you also have your cardiovascular regulation here. You got your heart rate and you got your vasoconstriction. Very important feature of the medulla oblongata. With that, let's go ahead and move on to the pons. This is going to be a short discussion. We're going to make this nice and easy. Pons just is another word for bridge. Again, remember that those tracks, those pulses going in and out of that brain are all having to cross through this portion. And at this point, in this pons, you start seeing bridges between the different hemispheres of the different portions of the brain. You got the bridge between the body and the brain, and then parts of the brain to the brain. You're going to see some crossing over to the cerebellum. You're going to see some crossing over to the cerebrum. You're going to see a lot of things going on here. It is a relay station between your voluntary muscles and your cerebrum and cerebellum, and it has maybe a tiny bit of control over your respiration. With that, let's go ahead and move on to the midbrain. The midbrain is located superiorly to the medulla oblongata as well as the pons, and just below or inferior to that of your diencephalon in your cerebrum. We're going to go ahead and hit some internal landmarks with the midbrain. First off, you got your motor impulses that connect here to the cerebrum and cerebellum and spinal cord again. It sends sensory impulses up, and as well as let motor impulses go down. Some important landmarks, you got the cerebral peduncles, corpora quadrigemina, substantia nigra, red nuclei, and medial lemniscus. We're going to go ahead and talk about 4 of those here shortly. First off, let's talk peduncles. This is, if we're going to make it really brief and short about this guy, pretty much it's all of your motor tracts to your body, to your cerebrum, minus your cerebellum. Everything for motor tracks minus the cerebellum. Corpora quadrigemina, this is a useful area if you have decided foolishly to cross in the middle of the Serengeti all by your lonesome, especially at night. Corpora quadrigemina, let's break down that word real quick. Corpora means body, quad means 4, gemina, some of you that are astrologists out there might notice that it sounds like Gemini, which means twins. You're literally saying the 4 twins body, or 4 bodies. So you got twins there, and you got twins below. You got the superior colliculi. This is your sight reflex. Now, I mentioned the Serengeti earlier. What I'm referring to is that the sight reflex, if you see something in your periphery, you notice something moving around in your periphery, your first instinct is to turn your head and look at it. That is what the superior colliculi do. The inferior colliculi has the hearing reflexes. So if you hear a twig snap off to the side or behind you, that is your inferior colliculi give you that reflex to go ahead and turn around and find what just caused that twig to snap. The midbrain also contains the red nuclei. It's red nuclei. They're red. Reason why they're red, you got a lot of iron pigment in there. Not only just from red blood supply, but because they use iron pigments. What's going on there is where the axons of the cerebellum and the cerebrum come to meet together. The substantia nigra, that just means black substance. It's that guy, this black band, darkish red, dark band of tissue there. These are neurons that release and contain and release dopamine. It helps. Dopamine is an inhibitory muscle signal for the neurons. If there's an abundance, you get a nice smooth looking appearance and your muscles move quite nicely. Without it, without that dopamine, without that or something's gone wrong with the substantia nigra, you have something called Parkinson's. Parkinson's is where you're going to have tremors, you're going to have some palsy, you're going to be fatigued. It's difficult to function and operate. In fact, it's kind of inhibitory in many cases, but it's not going to end your life, unfortunately. Oh, I almost said unfortunately. I'm glad I caught myself right there. There is some research coming out, which is great and wonderful. A notable person here, this is Michael J. Fox that's had Parkinson's. He's the gentleman from Back to the Future, did a wonderful job as an actor. And he's been a big proponent for the fight against, or for research for Parkinson's. Now, there is one more structure I want to talk about when we're talking about the brainstem. That is the reticular formation. The reticular formation is this little blue, indicated here by this little blue blob. It's not actually blue inside the brain. but it does indeed span your medulla oblongata. It spans the pons and it spans your midbrain. This is very important if you like waking up and being able to wake up and not being stuck in a coma-like state. It also has a role in helping you not be distracted and helping you tune out things and help you keep your muscle tone. If this gets damaged, you are not waking up again. You will be in a coma-like state because there is nothing to wake you up with. All of the senses minus one have ways of waking you up. So that means listening, sight, all that stuff gets incorporated into this reticular formation. And if you get any stimuli, like a bright light gets shined into your eyeball, somebody flicks on your bedroom light, oh, I hate that. Or they like jostle you awake, or if there's a loud noise, you wake up to it. It's going to wake you up. One thing that does not wake you up is smell. So most people die in fires at night due to smoke asphyxiation. They don't smell that smoke. That smoke does not wake them up. That smell does not wake them up because it does not go through that reticular, the stimuli for smelling does not go through the reticular formation. Hence why it's so important that you keep your fire alarms updated because you will not smell that smoke and you will die in your sleep. So quick little thing, remember the three parts, medulla oblongata, you got the decussation of pyramids, you got the olivary nuclei. Pons is that bridge where you start seeing that branching off, along with your midbrain, which has quite a bit going on with it. And with that, I believe we are going to pause there.